Okay, so for activity 4, say that the routes law together with the Antoine equation can be used in plotting the TXY diagram of a binary and ideal mixture, where X is the liquid phase composition and Y is the vapor phase composition. The equations for the calculations are shown. So we have the equation to find our Y, the equation to find our X, the equation to find our PI. So I realize that the Y and X have some saturation pressures in there, so we can find the saturation pressures. And these saturation pressures are dependent on what we call the Antoine constant. So these are the Antoine constants for the two species we are using. And the range for temperature I've been given is from TA sat, that's the saturation pressure of A, all the way to TB sat, the saturation pressure of B. The question is that uses information to plot a TXY diagram for benzene, that's A, and toluene B under atmospheric pressure. So it means you are doing this at a pressure of 1 atm, right? And then the question now goes on to give us the Antoine constants and says that all pressures are in millimeter mercury. So it means all the pressures calculated are going to be millimeter mercury. And if you're at atmospheric pressure, like what the question asks us to use, then it means you are going to be at 1 atm, which the question tells us is 760 millimeter mercury. So it means the pressure for our system is 760 millimeter mercury. Now, there's a hint here that says that use the Antoine equations to obtain the boiling point of benzene and toluene. So how you're going to do that is that if I want the boiling point of benzene, I'll put in the Antoine constant for benzene, right, at 1 atm. So I'll make this 1 atm or 760 millimeter mercury. So I know my P sat, I know my AI, my BI, my CI, but I don't know my T. So I'll just let MATLAB solve for T, and that becomes the boiling point for that species. So it's like in one situation, we can have, or let me put it this way, if I want to find the T sat, I know that maybe the PI sat, if it is going to be pure benzene, then the pressure is going to be the pressure of, it's going to be the same as the atmospheric pressure, which is 1 atm or 760 millimeter mercury. So I'll put 760 here for my PI sat and find what the corresponding temperature should be. Then I'll do the same thing for PB sat, right, and find what the corresponding temperature should be. So let's get into it bit by bit, and I'll be explaining as we progress. So what we want to do is that let's first start with the Antoine constant. So we can start with the ones for benzene. So this is just a comment that we are putting here so we know what we are doing. So you can see that AB, this is for A for benzene, 6.90565. And I can see that BB is equal to 1211.033, and then CB is equal to 220.79. Then I can do the same thing for toluene. So I can see that maybe AT is equal to 6.95464, BT is equal to 1344.8, and then CT is equal to 219.48. Now we know the pressure for the system is equal to 760. This is in millimeter mercury. Okay, before we can do the computation for the PSAT, we need to find the saturation temperatures, but we'll come back to that. Okay, so let's put in the expressions for our YA and XA. You realize that YA depends on XA and XA has its own expression. Remember, MATLAB is going to read our code from top to bottom. So if I should type this out first, MATLAB will read this first and not know what XA is. So I have to make sure that I define XA first. In the same way, if I should type this out, MATLAB doesn't know what my PSATs are. So I need to define those ones too as well before I continue. So we'll take it bit by bit. Let me make this PT instead of P so that we can all relate to that. Let me make a capital T. So we can all relate to that. Now, if I want to find, so let's write the expression for PB sat and PA sat. PA is for benzene, PB is for toluene. Right? So the question told us that A was for benzene, B was for toluene. So let's write out each of them. So if I want PA sat, this is going to be equal to, so we have the expression here, 10 to the power, so 10 to the power A for benzene minus B for benzene over C for benzene plus T. But remember, we are going to find a range of values for T. So because I'm going to find a range of values, I have to have my dot before all my vital operations. So like the exponential and then the division sign. So this becomes my PA sat. Then for PB sat, so let me copy this so that I just change the expression. So PB sat is now going to be for toluene, A for toluene, B for toluene, and C for toluene. Now I have the PA sat and PB sat. I can write the X expression. So I can say XA is equal to PT. Let me put it in a bracket. PT minus PB sat. Sorry, PB sat over PA sat minus PB sat. So I have that down. And I also have YA is equal to, so that's PA sat over PT. A minute. All of this times XA. So times XA. Now note once again, if T is going to be a range of values, then PB sat is going to be a range of values. PA sat is also going to be a range of values. So it means that when I'm typing out the expression with PA sat and PB sat, I still need to bring my dot indexing in there so that I don't make any mistakes. So I'll put a dot before every division sign and then before every multiplication sign. So I've defined all these terms. Now the major thing we need to do is to find our TA sat and then our TB sat. So these ones also have to come before because we are trying to put those values in here. So what I can do is that I can say that if I want to find TA sat, I can say that my P is equal to 760. So I'll make it PT no, let me do it this way. Let me say TA sat is equal to, so it will be PT minus, so I'm going to take this expression, so I'm going to replace this with PT, and I'll send all of this over to the other side, so it becomes minus all of that, right? Because I have an expression like that here, let me just copy it. So minus 10 to the power all of that. So let me put that one here. This is going to be for benzene, right? This is what I'm going to get. Then I can say that solve for T. So I'm going to solve TA sat, and I'm going to solve it for T for speed, so that it solves and gives me the value of T at that point. So let me just make this let me use a different expression for this. Let me just see, this is, let me call this equation 1. I think that's better. Let me call that equation 1. So this becomes equation 1. I want to solve equation 1 for T. So I'll put here TA sat to be equal to that. TA sat should be equal to that. Then I'll do the same thing for B. So I'll copy this part again and I'll replace it with the expressions for B. So I can say equation 2 should be equal to this, and then instead of B, I'll make all of them T. And once again, I'll solve for T and I'll call that one TB sat. So here TB sat should be equal to solve equation 2 now for T. Now my range of values for T, I can see that my T, the T that I'm going to be fixing into these expressions down here, the T is going to be equal to T from, it's going to start from TA sat. I want to increase it by a value of 0.1 and end at TB sat. This is what we are going to get. So before we continue, let's run to make sure we don't have any errors. If there are, we'll look at where they are and then correct them. So it says line 8, line 8, line 8. Let's see. Or recognize function T. Yes. So how to make it a symbolic variable? Yes, that's true. So before I can write out an equation for MATLAB to solve, I need to define the variable and make it a symbolic variable. So let's try that one more time. Let me call, I don't want the T here to conflict with the T I've already done. So let me call this T T naught, right? So that it doesn't conflict with the things we are doing later. So this is T naught. This This is also T naught. Okay, now let's try running this and see to make sure there are no errors. Okay, so there are no errors showing. So now let's try our plot. The question says that we should plot a T XY diagram. So we'll plot T against X, and then we'll also plot T against Y. So I can say that plot T against XA and then T against YA. So let's plot this as well and see what we have before we continue. Okay, so we have this graph. This is what we actually expecting. We expected to get something like this. So the last part says that we should now label everything. So I can label and say X label, open my bracket, bring my inverted commas in there and call it XY. So we are calling the X axis XY. And I can do my Y label. I'm calling the Y axis T in degrees Celsius. And then the last one is we are looking at the legend. Oh, sorry, there's also supposed to be a title. So I can type title. This is a T X Y diagram for a benzene toluene system. And then the last thing is going to be the legend. For the legend, I'll type the first thing. So say TXY curve is called bubble points curve. So I plotted TXY first, so I can type bubble points. TXY is going to be bubble points, and then the other one, the TY curve, is going to be dew points. Okay, so now if I should run this now, I'm going to have my title, I'm having my legend, I have the labels for the axis as well. So this is how we go about this question, right? And I think the major part of this question has to do with the parts where we have to make T the subject. So I'll just briefly go over it again so that we get the understanding. So what we are saying is that if we want to find our P, okay, if we want to find our Y, we need to find our X. If we want to find our X, we need to find our saturation pressures. And to find our saturation pressures, we need the Antoine constants and the temperature. But the temperature has been given to us in a range. And this range, we need to get TA sat and TB sat. So TA sat is going to be the temperature, saturation temperature at a given pressure. And for the question, the system's pressure was 760 millimeter mercury, which is 1 atm. So that's the pressure. So if I find the T at the given pressure, I'll be able to find the TA sat for each of the species. So I'll put in the Antoine constants for benzene first. That's what we did over here at equation at line 9. We put in the Antoine constants for benzene first, but I call that equation 1 and I sent everything to one side of the equal to sign. So it becomes Pi sat minus all of this is equal to 0. So that's what I've done over here for equation 9, right? Then we want to solve for T, right? Given the P to be the system's pressure. So I'm going to replace the Pi sat here with the total pressure, right? So that will give me the temperature at which only benzene will boil at that pressure. So I'll solve for that. So I'll type my TA sat to be equal to, I'm going to solve equation 1 for T naught. And I'll do the same thing for toluene. So we're going to solve equation 2 for T naught in that case, and that becomes a TB sat. So I can now set my range for TA sat to TB sat, right? And because you didn't want the T from this part here, what we are solving for, to conflict with the T down here, we use a different symbol. So we use T naught and T so that it doesn't conflict in any way, right? So this is how we go about this question.